Okay, let's get started. How are you? I'm happy to be with you today. Today I'm going to be talking to you about the logarithmic function and the different properties and rules of this logarithmic function, relation between the logarithmic function and the exponential function. So let's get started. Logarithmic function. Definition. The logarithmic function is in the form y equals log base a of x is read as log x to the base a. Then if I'm going to convert it into the exponential form, I'll get a to the power y equals x. Here is the exponential form. And here is the logarithmic form. But from our definition that you will find that x must be greater than 0, y equals in general. We have y equals log x to the base a, and the conditions must be satisfied to say that this function is a logarithmic function. Then three conditions must be satisfied. Number one, x must be greater than 0. Number two, a greater than 0. Number three, a doesn't equal 1. Then these three conditions must be satisfied to say that this is the logarithmic function, and these three conditions determine my domain. I'm going to give you an example. Determine the domain of y equals log x minus 5 to the base 2 minus x. Here we have the three conditions. Number one, this guy must be greater than 0, x minus 5 greater than 0. Here we have x greater than 5, and the interval is from 5 to infinity opened interval. Number two, here we have this guy must be greater than 0 and x less than 2, and this means that the interval here is from negative infinity to 2. Third one, that this guy mustn't equal 1. And here we have x does not equal 2 minus 1, 1. This means that x does not belong to 1. The intersection of the three sets, then we will get that the domain equals five and infinity intersection, -8, negative infinity, and 2 intersection, and if we cancelled out one from them, then we'll get from 2 to 5 reference set 1, and actually 1 does not belong to this set, then this is equal to the opened interval 2 and 5. Here is the domain. Then x takes any values between 2 and 5, and this means that we have a logarithmic function or a valid one. Let's move on to the famous logarithm. We have two famous ones. The first is called the common logarithm, and the other is called the natural logarithm. What about the common logarithm? Log a to the base 10 is written as log a directly, and we cancel out 10. Log base e to or of a is equal to ln a, cancelling out log e or converting it into ln a, where a is called Euler's number and is equal to 2.71828 1828 and so on. Here I'm going to talk about the rules. Rule number 1 is that log a to the base a is equal to 1, where a belongs to r positive difference 1, and property number 2, log 1 to the base a is equal to 0. Property number 3, that log b to the power m to the base a is equal to m log b to the base a, where a, b, and m are numbers. Constants. But here we must differentiate between the numbers and solving equations. In case of the solving equations, then we have different technique. I'm going to give you an example for this. Here we have log 10 to the power 3 is equal to 3 log 10, and log 10 is equal to 1 is equal to 3. But if I asked you about solve example, solve log base 2 of x squared equals 2. Here we have a different technique to solve this example. Then if I take out 2 here and put down here before log, then I'm going to put the absolute value here, and this is equal to 2 log base 2 of absolute value of x is equal to 2. And here by dividing by 2 here and here, then you'll get log absolute value of x to the base 2 is equal to 1, and converting from the logarithmic to exponential form, then we get absolute value of x is equal to 2 to the power 1 is equal to 2. Then here we have x either equal 1 or x equals 2, sorry, positive 2, or x equals negative 2. Then in case of, in general, in case of if we have here an even power, then you must put down the absolute value or the equation. I'm going to give you another example. Solve for x log 2 of x to the power 3 equal 3. Here, pay attention, we have odd number here. Then I'm going to write this in the form 3 log 2 base 2 of x equal 3. Here we have odd power. Then we take out the power in front of the logarithmic function and then complete our solutions. By dividing by 3 here and here, then we get log base 2 of x equals 1, directly x equals 2 to the power 1 equals 2. Then my solution set is 2. Then in general I can say that in solving equations, log x to the power m to the base a is equal to m log absolute value of x to the base a, or m log x to the base a. And here the first one in case of m is even number, and here in case of m odd number. Property number 4. Product property. Log base a of xy is equal to log x to the base a plus log y to the base a. Property number 5. Log base a of x over y is equal to log base a of x minus log base a of y. In case of division, then we have a subtraction of logarithmic functions. In case of multiplication, then we have addition for the logarithmic functions. Property number 6, and property number 6 is really important property, that is called base change property. Base change property. In this property, then here we have log b to the base a is the same as log b to the base m over log a to the base m. Then we change it, the base here is called base change property, or is equal to log b over log a. And inshallah by the next time, inshallah, I'm going to give you different examples on this property. Property number 7 is called multiplicative inverse property. Log b to the base a is same as 1 over log. Then I'm going to interchange the position of a and b, a to the base b. Example. Find 1 over log xyz to the base xy plus 1 over log xyz to the base yz plus 1 over log xyz to the base zx. Here I'm going to use this property. Then we have 1 over log, then I'm going to interchange the position of xy with xyz here, with position of yz with xyz here, the position of zx with xyz. Then here we have bases xyz. Then is equal to log xy to the base xyz plus log yz to the base xyz plus log zx to the base xyz. Log plus log plus log, and then here we have the same base. Then I'm going to use the product property is equal to log xyz base xyz to xy dot yz dot times zx. Here we have log base xyz of x times x square, y times y square, z times z square, x square, y square, z square. Then in the simplest form is equal to log xyz all to the power 2, take 2 out of the parentheses, to the base xyz. Here is equal to 2 log xyz to the base xyz, and here we have 2 times 1 equals 2. This is Young's. Property number 8. For property number 8 is really important property also. And here we have a to the power log base a of x is equal to x in general. For example, if x belongs to a positive difference 1, find x to the power log b of base x of 5. Then this is equal to, in the simplest form, 5 without making any computations. Property number 9. Property number 9 states that a to the power log of base m of n is equal to, here I'm going to interchange the position of a and n. Interchange the positions of them. And here I'm going to get the equal to n to the power log base m of a. I'm going to give you an example here. Example. Solve for x. Here we have (100) to the power log x equals 9. By using this technique, then I'm going to interchange the position of 100 and x directly. Then here we have x to the power log 100 is equal to 9. And this log 100 is equal to 2. Then here we have x squared equals 9. And by taking the square root for both sides, then we can get x equals positive or negative 3. If I'm going to check my solution, then negative 3 is cancelled out as we don't have an logarithmic function in negative. The negative is cancelled out. Here we have our solution equals 3. Property number 10, and is very important property also, is that log a to the power m base a to the power m of b to the power m is the same as log base a of b is the same as log base a to the power n of b to the power n. Here I'm going to give you an example for this part. Example. Log 49 to the base 25 is the same as log. If I take square root for both these numbers, here I'm going to take a square root and here I'm going to take a square root, then I'm going to get log 7 to the base 5. If I'm going to raise this number to the power whatever 13 and this number to the power 13, then I'm going to get is equal to log 7 to the power 13 to the base 5 to the power 13 and so on. Example. Log solve for x. Log 25 log base 25 of x squared equals 2. Then find x. According to this property, then I'm going to find the square root of this guy and this guy, and here I'm going to get log, but pay attention, we have a positive even power here, then log absolute value of x to the base 5 is equal to 2. And here we have 5 to the power 2 equals x equals 25. Absolute value of x, sorry. Then here we have x either 25 or negative 25. Here I'm done. I finished all the properties of the logarithmic functions and the relation between the logarithmic function and the exponential one. And the next time, inshallah, I'm going to solve different equations and inequalities on the logarithmic function. Until the next time, see you. Bye bye.